Hello, my name is Ashton Chikala, and today we'll be going over our senior design capstone project. Our sponsor BPMI tasked us with creating an explosive gas mitigation system. This project consisted of the design for a gas mitigation control panel, the choice and analysis of the igniters, and the interface between these two items. Our design development process started with an overall initial design sketch. On the left-hand side of the picture, we have the monitor room with the gas, propane in this case, and the final podium design. On the right side, we have the combustion chamber, piping, and all the necessary equipment mounted to a wall where the gas will be entered and exiting. Next, we have the user interface, before and after pictures of our CAD designs. And lastly, we have the block diagram that interweaves all the different physical components of our design. Next, Jacob will talk about the fabrication and testing.
As you'll see on the bottom of the slide, we have two pictures of our finalized products. On the left, you'll see the combustion chamber. From left to right, you'll see the exhaust fan feeding into an intake tube, which then feeds into the combustion chamber where we will be combusting the propane in certain concentrations, and any byproducts would be exited to the right with an exhaust fan. On the right picture, you'll see the finalized user interface. You'll see that it's interconnected with the PLC, talking to the different components on the interface panel, such as the indicators, the switches, and the fuses. Next, I'll have Mark talk about the future material considerations.
For our primary future considerations, we would like to install more functionality into our prototype, the most important of which is our ignition method. Initially, we conceptualized this idea using xenon trigger coils, which are a safer, low-power device. For a more industrial application, something like an oil burner ignition transformer would be more appropriate. Additionally, our combustion chamber was comprised of a woven ceramic, which has poor pressure properties. We would have liked to select a more robust material in order to withstand high temperature, high pressure combustion. For our user interface, we were not able to fully fabricate the podium and instead was only able to 3D print our control panel containing only the necessary information. Now Roy will discuss our future electrical considerations.
So due to the constraints that we had, the LCD display screen would have implemented the pressure sensor, the gas sensor, and thermocoupling. This would have been implemented onto the PLC itself and would have shown the parameters along with it. Along with the PLC, we were unable to make any analog inputs and outputs due to the constraints of having only Boolean inputs for the PLC itself. Finally, for the external circuitry, due to time constraints, we only had to implement with breadboard. However, with the PCB, we would have had a more fleshed out design for industrial applications. Finally, thank you for listening. And finally, we would love to thank BPMI, our sponsors, for all the help they've given us.